So there is a live demo, and hopefully it works. You'll see some domain names. Just don't DOS them while I'm trying to DOS them as well. So as long as we go through that, we'll be fine. I work for a company called Akamai. Some of you guys might know who we are. Just to level set, we do content delivery of some of the largest websites in the world. So we see roughly between 15 and 30% of all web traffic on the internet. So I put this together for one of our conferences, and I thought it would be a good thing to present here, just based on our visibility and what we've done with some of our customers, as well as what we've seen kind of in the wild. So I'll show you kind of how easy it is for one botnet in particular to be built up. I do not have the command and control in the demo, but I'll explain kind of how easy it is to control these things. I'm going to actually execute it with my browser. And you can extrapolate from that kind of how easy it would be to create a command and control infrastructure around this. Okay, so I'll do some level setting. We'll have some discussion, and we'll get into this. We'll do a live demo. So you already got my intro. Some security concepts, really high level. What are the attacker motivations? I think we all understand some of this. It's going to be political, financial, either them or you. Glory, or it's Tuesday and they just feel like attacking somebody. We've seen a lot of that lately. We've also seen a lot of extortion. I don't know if anybody in here works for the government, but we've been seeing, and it's not a lot of extortion. They'll take down somebody's infrastructure and websites, and then they'll ask them for $150 to stop. So it's not a lot of money, but it's a huge impact for those businesses. Some of the impacts that we've been seeing, it's going to be data loss, service interruption, fraud. We saw some using botnets, DDoS, as well as brute force bots. We were seeing some, let's say, commerce customers. They were getting lists off the internet, going through there, doing carding attacks, buying goods, converting those goods into cash pretty easily, and using just these really simple botnets to be able to execute those attacks. Attack methods, it's going to be your normal DDoS attacks. Sometimes it'll be man in the middle. Over the last few weeks, we've probably seen more of that than we should. Hijacking redirection, so we've seen a lot of attacks against DNS infrastructure, either injecting their own DNS to redirect them somewhere else, or alternatively just getting your credentials going into your DNS infrastructure and redirecting it somewhere. We've also been seeing BGP hijacking. So whether it's on purpose or by accident, we've seen a lot of companies have pretty big swaths of the internet hijacked and funneled over to Asia. Just leave it there. And then all the other application layer attacks. So SQL injection, which oddly enough, I'm not as concerned with as I used to be. I'm much more concerned with command injection or remote file inclusion attacks now. Just some level setting if anybody wants to shout out what, again, this is a web application centered discussion. If anybody has any concerns that they think are really important to their organization or them, just shout out some stuff and maybe we'll cover it here. What's that? Watering the hole? Okay. I don't know that one. You'll have to tell me that one in a minute. Yeah. Anything else? We'll probably cover some of the things that you guys are concerned with, and maybe some that you're not as concerned with. Anybody use cloud infrastructure for their websites, applications? Yeah? Anybody else? Yeah? That deeply concerns me now, so, and I'll kind of explain that in a second. So what keeps CISOs up at night? I think we all understand this because they yell at us and tell us, make it not happen. I might lose my job. Data breaches, that's really bad. Service availability, that costs money. Billing attacks. So if you're using AWS or if you're using other cloud providers, it's really easy to scale up. They want you to scale up. But that hits your bottom line every time. So if you can't predict the billing structure of your website, so it's usually a gradual ramp, and if you piss me off or I'm a competitor and I say attack this company, maybe we'll affect your bandwidth, we'll affect your utilization on the number of instances you use over a period of time. It's definitely a concern. I extrapolated for one customer what their overage charges would have been if they had to scale up infrastructure and it was in the hundreds of thousands per month. So if you're not planning on that adjustment, you should plan for it now. Usually it's one of those things where you work with your provider and say, hey, do you have any cost capping or fee capping at a certain level if we're under attack, or we're scaling up rapidly for some sort of event. And the last one's brand protection. We always talk about that one, but people still shop at Target. People still shop at Marmax. Who knows? I think it's like a 6-month cycle, and people usually forget what happened. Okay, so what did we see? And again, it's about 30% of traffic on the internet that we're going to be seeing is from a web application standpoint. DNS hijacking, we're seeing that because that's how our infrastructure operates. So we see anybody hijacking DNS from a customer, we'll see dips in traffic, that type of thing. DDoS, botnets spreading on Linux and mostly Linux machines. Windows machines, we haven't seen too much of that, except for if they get some malware on the machine from an internal infection standpoint. And from a DDoS perspective, we see everything. It's SNMP, DNS, NTP, runs the gambit. And then this is actually a little bit old. The last attack that we saw was about 290 gigabits per second. A lot of customers come to us and say, hey, what happens? What's the biggest attack you've seen? And we go in there and we say, well, we've delivered lots of traffic, but the biggest attacks we see are usually in the hundreds of gigs. And then customers think they can scale up to be roughly that size, and it's just not feasible. And you don't want to do it. It's a lot of management nightmare. And you have to globally distribute that architecture. It's a pain. Like I was saying, bots aren't limited to HTTP, HTTPS. You'll see in a second, I'm executing an HTTP attack, but I could easily transform my script to do DNS, NTP reflection, pretty much whatever I want. SNMP walking, reflection. We were having an internal discussion, and we were saying, oh, the new thing's SNMP. And I said, no, the new thing's any UDP traffic that doesn't verify origin or source address. If I can send you a UDP packet and say that it's coming from somewhere else, you're going to send the response there. So I just have to pick a protocol that's going to send a beefy response on a little request. That's the next attack. So I said just pick one. Okay, Brobot in action. So Brobot's the tool that we got some code for, so I'll show you what that looks like. It's ridiculously simple, but it had a huge impact on pretty much every bank over the last couple of years. Lots of downtime. I don't know if you guys kind of remember all the banks that were down. I'm not going to name any names, but pretty much all of them were attacked and had some sort of outage over that period of time. It wasn't a small outage. It was hours or days. And the group that was executing these attacks was the Al-Qassam cyber fighters. So they were doing DDoS attacks, and they were also attacking the application infrastructure as well. So what are we seeing the attackers doing? So just over the last few months, we've seen services come online. So you can go buy services. They scale in the cloud. So they're going to execute these things like anybody else using a cloud would. So they'll buy an AWS instance. They'll rotate the IPs. They'll execute the attacks through that infrastructure. Amazon doesn't necessarily care. They're going to bill for the traffic. They're going to use a stolen credit card, so they're going to bill whatever credit card they put on file. They're using the same techniques that we use to protect to attack. Makes sense, right? So here's the question. Why is it so easy for them to be able to execute these just monolithic attacks? Well, how many people run a PHP site? I should see everybody's hands up, but PHP is probably the, so you got a WordPress site, you got Joomla, Drupal, whatever. A lot of big companies use this stuff for marketing sites, campaign sites, things that they don't necessarily care about. But the thing is, when you're hosting these on cloud infrastructure, you've got lots of bandwidth. You've got easily injectable machines, because I'll go buy a template on some template provider. It's got Tim Thumb drop-in. It's got some other drop-ins that nobody knows are there. I don't necessarily update them. I'll go buy a template. I don't know what's in there. I'll go scan it periodically to see if there's anything I need to be worried about. But for all intents and purposes, people don't look for that, and WordPress or these other frameworks don't tell you about it because they don't know that this drop-in is this version. If you use their plugin infrastructure, it'll update through that. But if it's a drop-in, it's completely different. And there's just so many injection points out there that you can execute. I think I was going to the vulnerability database, and there were 2,100 remote file inclusion vulnerabilities out there. So you just search for one. You don't have to find it. You just search for one that's out there. I guarantee you that there's over 1 million machines that have not been updated that you can execute that against. You can do a Google dork to be able to see if somebody's using an outdated version of TimThumb, run through that, grab all the links off of Google, execute your injections on all those hosts, and now you've got a botnet of X hundreds of thousands. And they're very well connected. So if you're on AWS or you're on GoDaddy or you're on one-on-one hosting or whoever your hosting provider is, they've got big pipes. I mean, it's usually between 20 to 40 gigs on each one. And then if you're at AWS, it's hundreds of gigs per data center. And to my knowledge, they don't necessarily limit the bandwidth depending on which kind of box you have. I think we all understand this. If I own your box, which means I got something that I created onto that box, I control it. I own your service, I'm going to own your customers, and then I'm going to own your reputation. Okay, so what are the tools and techniques that I'm about to show you, and then we'll get into the actual demo. Okay, so why I built this using WordPress and OpenCart is WordPress is the predominant CMS on the internet today. So it's roughly about, when I wrote this, it was roughly about 71 million sites out there use WordPress, and they're on multiple hosts out there. You've got lots of drop-ins that you can execute remote file inclusion attacks against, lots of bandwidth, and it's really easy to find on Google because everybody wants those things searchable. And if anybody's used TimThumb, it's in the links. So you can search for the caching directories or the TimThumb file name or the pattern that TimThumb uses to actually pull external content and cache it. You can figure out where they're pulling content from, which means that they've allowed it to be pulled from that location. And then you can insert your code there and pull that locally as well. So if it's on Flickr or some other location that you can pull raw textual content, you can pull it, dump it on the file system, and then be able to execute that. Okay, so we've got WordPress. We will execute the attacks. We'll inject some things onto the WordPress. I've got a TimThumb. Please don't hack the machine while I'm doing this, but we'll pull a file locally onto that system. We'll execute a DDoS attack, and I'll actually show you the impact on a unprotected machine and then a machine where we're using a different type of protection mechanism and show you the difference in the CPU utilization. It's extremely easy to take down web infrastructure using a very, very small box. I'm using the smallest AWS instances. Actually, I'm using DigitalOcean, but I'm using really, really small boxes. Anybody use DigitalOcean? I moved over from AWS, so I like them. It's good stuff. I'm not endorsing a product, but I like them. Okay, so the WordPress system, once we inject all of our scripts on there, we're going to execute the DDoS attack against OpenCart. I used OpenCart because it's a pretty well-known carting system to sell products on the internet. It's open source, it's freely available, and it's actually pretty good. Everything when I created this was fully patched, so I think I'm still pretty good. I think I updated everything. You never know. Again, it's all cloud hosted. I think everything's fully patched and updated. Don't look at the screen and then tell me that it's not, but I think it is. Okay, so WordPress, it powers about 1/6 of all sites on the internet. Kind of told you about that. Joomla, Drupal, people use that as well. If it's PHP, you're going to have the same problems. I don't know what it is about PHP, but either it's terrible developers are releasing code or people just don't realize how easy it is to be able to execute these attacks And PHP doesn't really lock down the infrastructure very well, so you need the access to write files to a disk. If your script or your application's not cleaning up or validating content very well, I mean, it's pretty easy to get this stuff onto a box and be able to execute these attacks. Okay, why did I pick Tim Thumb for this? Because it is I had to find something to be able to get something out of the box that is in a lot of themes. It's being used pretty widely across the internet. It's something that we've seen being used to execute these really massive, 300 to 20 million requests per second attacks against customers. So I went and looked, okay, what's the attack vector that they're using? And it was generally always a well-connected hosting provider, PHP site, and digging in a little bit deeper and looking at how Tim Thumb works. Tim Thumb was the culprit for most of those, and they infected hundreds of thousands of machines, and they were rotating IPs in and out just en masse. Why did I pick this one? Okay, it's a small PHP script. It's supposed to be used for pulling external image content, resizing it, and allowing you to cache that locally so you could serve it faster. If you're doing any content delivery, you can use that as well to push it out once it's stored locally. Makes things a lot easier for you. Fits your site. If you're using responsive, it'll resize it the way that you want it to look. And it's pretty well distributed out there on a lot of sites. So I use this one. When I was digging into it, I wasn't sure how easy it would be to actually get a remote file onto the system and be able to execute a script. It was incredibly easy. The way that it works, let me see if I've got a slide on it. If not, I'll just talk to it. Okay, so the way that it works is when you basically append a source location of an external image file, or any file, it goes out, pulls that locally, and then so it'll cache it locally, and then it'll start to try to resize it, figure out what MIME type it is, cache it in the different formats that you want, and that's pretty much it. So it doesn't validate. You can do some origin or external origin validation, so certain domains, things like that, but a lot of the domains that are default in that list can serve textual-based content. So I can put a script out there, pull it locally, and then have my PHP script run. The way that it caches it locally is it does an MD5 hash on the entire URL that you're pulling in as the source content. And it doesn't seed the hash or anything like that. You don't put a seed value in there, just MD5 hashes the whole thing. If it's external, it appends an external underscore and then the MD5 hash, and it keeps the file extension. So if it's a PHP file, it's going to keep that PHP file extension. So I'm going to be able to just natively, by hitting that external underscore MD5 hash.php, I should be able to execute that script on the box. And because of the file permissions that you generally have to set up to be able to cache those files, you can generally, if people set it up the way that they do out of the box, you can execute these scripts natively on the box and be able to figure out what are they running. Do they have curl? Do they have some other thing that I can execute DDoS attacks? Can I use FTP? Can I do brute force? If you just run a PHP info script on there and you dump out what you have available, you can customize your attack to be able to execute whatever you want from that host. Not to mention you're on the box, you can dump out files, you can transfer things externally. It's pretty bad. If you want, I can actually pull up the Tim Thumb, or you can actually go look at Tim Thumb itself. It's open source project. Not a lot of input checking. In fact, if it validates and then it tries to resize the image and it can't resize the image, it just kind of leaves the files out there. So it doesn't even clean up after itself. And it doesn't restrict PHP file names because you could have a dynamically generated image or something like that. It's terrible, terrible. I mean, I like it because it makes demos pretty good. But,
I actually had a WordPress hack with that exact file.
Oh yeah, no, it's terrible. There's lots of PHP, backdoors or scripts that you could load on these systems, and it's terrifyingly easy to do it through a Tim Thumb. You could search Google right now for anybody running Tim Thumb and start just testing it. And if you can get a PHP file on there, they don't change the path. So if you know the MD5 the MD5 hash of the location you're pulling from, and it's a PHP file, just try to run it from their cache location. If it works, then you've got a system you can infect. I mean, don't do that, but yeah. All right. So what we were saying is that I'm going to show you some code from Burrbot just to show you how easy it is to bring down really heavy infrastructure on the internet. This attack and these scripts were used primarily by the Al-Qassam cyber fighters. It was an Iranian, I guess, community. It wasn't necessarily the government, but it was a group of activists within Iran. There was a video posted on YouTube. They got angry about that, and they said, we're going to execute these attacks and affect X amount of financial burden across the financial industry. So it's all, it's rough numbers. They said, we'll take you down. This is how much we think it costs you, and we're going to do it until we incur this amount of billions of dollars in impact. And they were pretty successful. So very simple script, easily uploaded, easily executed, and it creates massive traffic and CPU utilization at the origins. Can you see this? So the Burrbot code is quite simply a curl function that iterates through some randomized strings, has a target, and just executes thousands and thousands of curl requests against that target. That's it. So they did do one thing right here. So there's a thing called a cache busting technique. If you're caching traffic, your caching provider is going to just serve the traffic. They don't care. Their infrastructure is many, many, many terabits, tens of terabits of traffic. They'll serve that content all day long. If they've got fee protection, you're good. The problem is that the way that most of those, and again, this is pretty customizable, but you have to think about it when you're implementing it. If you randomize query strings on the end of content from a caching provider, usually it's going to go back to the origin because it thinks it's a different piece of content. So the one thing that they did right here was they were randomizing strings at the end of the actual URLs. So what you would need to do to be able to prevent something like that is you have to ignore those query strings on the end of those URLs. So then the next thing that they're going to do is randomize the file names. Okay, well, what do we do in that instance? Well, if they're randomizing the file names, we can do things like rate controlling or looking for patterns within those requests. So it gets a lot more complicated. And that's kind of what I'll show you in a second. Really easy to execute, really, really hard to defend against. Especially if they've got hundreds of thousands of IPs they can rotate in and out. Your rate controlling usually times out after a period of time. So you'll block an IP. That IP will be blocked for X amount of time. Okay, well, I'll rotate another 10,000 IPs in. And I'll just do it every 5 minutes. Okay, I'm going to show you the attack right now, and then I'll explain some of the defenses and actually show you one thing that works pretty well. All right, live demo, don't mess up. All right. So what you're going to see here at the top is I've got my OpenCart system on the left top. I just have HTOP running up here. And then on the other side, we have another system that's our protection system. We're not going to execute the attack against that one. We'll do that after the initial attack against our demo system. Down here at the bottom, so let me log back into my attacker machine. All right, down here at the bottom, I'll just show you how it caches the files locally, because it's, okay, so my cache is clear right now. I'm just going to use my browser to execute these attacks. The first thing that I'm going to do is I am going to, well, first I'll show you the OpenCart system. This is default out of the box. I did the, normal install. It's running MySQL. It's pretty simple. I have a domain that just dumps out the textual PHP scripts. So I've got one here that's PHP info. If you actually wanted to see the full Burrbot script, this is what it looks like. I've got, I've got my targets. It's got all the looping statements. It's got, it's got some randomized query strings. So it's what it looks like. I wonder how many people are actually pulling that down right now. Okay, so what we'll do is we'll actually load the script on the server, and I'll show you what that string looks like. Okay, I get an error, great. I'm using an older version of Tim Thumb. I think it's a couple of years old. I had to have something that I could inject into, right? So you do the Tim Thumb script, so that's that .php script at the end of the original. The query string is source, and then the source that I'm pulling from are my bad scripts. So in this case, it's that PHP info file. And like I was telling you before, because we know the way that Tim Thumb stores that file locally, we'll be able to execute that just by going to the cache location and using that string. So let's execute it. I'll show you what this looks like. Okay, so it dumped out the PHP info, so this is great because now I know everything that I can do in this box. I know where I am from a location standpoint. I know what modules they've loaded. I know what I can do from an attack perspective. If I'm going to build a big botnet, what I could do is load this in there, or load another script in there that just checks for the components that I need, and then loads the appropriate scripts in there afterwards, and then executes multiple attacks against multiple different hosts. The really interesting thing is the people that have been compromised by this, do they get like an overage bill? Do they see that, at some point the attackers are also affecting the billing cycle of those customers unless they have like an unlimited plan or something like that. But even the ISPs I don't know if they don't care or they don't do anything about it, but they're seeing these huge traffic spikes, and we're not seeing those IPs being taken down. So either they don't know that it's happening, or it's under their radar, or it's not hitting some billing cycle and somebody's going, why do I have like a $10,000 bandwidth overage for this month? I would notice because, it's on my credit card and I don't want to get a huge bill. Okay, so I've got my DDoS attack scripts. Those DDoS attack scripts have, I've got two of them. I've got one hitting my unprotected system, which I'm going to show you right now. So this is, I'll load that attack script here. Okay, and again, just to show you what it looks like. So it caches these things, external unscore, if it's the external file, it's got the MD5 hash, and then it uses the extension that it pulled. Really, it's terrible. And then if we want, we can actually see what's in these files. Okay, so that's my DDoS attack script. And what you'll see here is, again, on the top left, that's our open cart system. And the CPU right now, because I'm running HTOP, is roughly between 1% and 2%. Really small box. So let's execute the attack. I could do a curl statement to execute the attack. I could have my command and control infrastructure that knows where all my bots are, execute these. The only thing you need to do to execute this attack is hit the script. It spins up its own worker process. If you're using Apache or some other PHP intermediate, it spins up its own worker, and that worker will stay, if you set the right variables, that worker will run until it's done. Which is, if you're attacking somebody, that's what you want to have happen. Okay, so we'll execute that. I'm just using my browser to execute it. So we'll hit our unprotected machine. Now it's executing that. And this is one attacker, one instance of a worker on that machine, and it's generally going to peg that CPU right around 100%. If I hit refresh, if I spin up extra processes or workers, we should be able to peg it, see if we can get it all the way up to 100%. Oh well, 96% is close enough. The site's probably unusable, or it will take so long for somebody to get to that site that they're going to go somewhere else. If you're dealing with commerce sites, people are fickle. They're going to go immediately to another provider that they can buy the product from. If it's a banking site, you have a little bit more leeway, except if you can't get to your banking site to transact business, then lots of people are in lots of pain. If it's another one is if it's a trading site. So if you're using an online trading provider and you can't get to their site and you need to execute trades, The fallback is you call them up. If everybody's calling them at the same time, you're gonna have some issues. If you can't execute those trades when you need to execute them. Yeah. This was, so it doesn't matter. So they used MD5 as the hashing mechanism for the file name so that you could identify what's been cached. They could use whatever they wanted. It's just an identifier for that file name that they pulled locally. Yeah, so MD5 is just the storage location that they're gonna cache that. The easiest way to understand why they did that is if I'm pulling a file locally, I don't necessarily want that entire URL string as the file name. That's not gonna work for me. So they MD5 that source address, and that's what they use as the file convention, the file name. So it doesn't really have anything to do with the hash other than you know what the file name is going to be when you store it. The one thing that I would have done is I would have seeded the value and probably used a bigger hash. That way it's a little bit harder to figure out what that seed value is, so you don't necessarily know what the name is when it stores locally. But they didn't even do that. So how do I stop my attack? I just restart Apache. So I can restart all the workers, and then it should die down to 0. One interesting thing that we were seeing when we were executing these attacks is that if you have very fast protection at a pretty big scale, you're going to start impacting the machines requesting the content. So you're going to start impacting the attacker, and the attacker's CPU load starts going up, and yours kind of stays the same. So it's just a byproduct there. So how do you, let's see if I've got some slides on this. How do you defend against this stuff? Defense is really, really hard. So they can change their scripts a lot faster than you can change your protection. Rate controls work pretty well unless they have lots and lots of machines that they're attacking from. So they're going to rotate IPs in and out. They're going to rotate attackers in and out. You know, we were seeing roughly between 50 and 100,000 IPs at any one time. So it's, I mean, they just have this huge infrastructure they can pull from because the internet is kind of the Wild West and people don't update their stuff. You know, there's sites out there that I probably have that I forgot about, which is not a good thing. But I haven't gotten a bill on my credit card yet that's a little higher than I expected. A lot of people are using AWS now, really big pipes. You know, they can randomize content. They can see what you're actually using as protection. Rate controls have been the most effective for us in it being able to defend against the DDoS attacks, but brute force or low volume attacks, now you start looking at, okay, how do I prevent them from hitting my resource intensive stuff? I can cache, you know, it doesn't matter what caching provider you use, you can cache everything at the edge of the network. So it doesn't have to hit your infrastructure. I would want to say that on pretty much all sites, you can cache 95 to 97% of your content. Images, CSS, JavaScript, your base pages. The only thing that you might not necessarily be able to cache would be dynamic content pulls. So, and you can also cache those for a period of time. So what I would say is cache everything you can at the edge. If you have to pull content, so your search, your login, anything that might be dynamic that has to be refreshed constantly, those are the things where you need a deeper level of protection. So rate controls might not work if they've got lots of IPs. So how do we prevent them from actually going to your origin and executing those requests? Well, if it's a bot, it has to know where to put those values, right? So if it doesn't put the values in the right spot, you could block it. If it doesn't have the things that you're expecting, you could block it. So one of the things that that I was working on and some of my friends were working on is how do we actually prevent somebody from understanding where and how to get content into those locations, and still retain the cacheability of that content. Again, if it's a DDoS attack or somebody's just trying to scrape your content or it's any type of bot, how do you prevent them from actually executing that request to your origin and hitting your origin, but still maintain the usability of your infrastructure and being able to cache that at the edge? So, you know, there's really easy ways you can change content fields, ID descriptions, all that kind of stuff, and you can randomize locations of content. The question is, how do you And we'll just go to this system. I'll actually show you kind of what it looks like. How do you do that and still retain cacheability? Because if you're randomizing content, like we were saying before, you break caching. If the content changes every time you push it out, you break the ability to cache that content. So you have to have some out-of-band mechanism to be able to do that. In this instance, it's my personal email address if you want to email me. So what you can do is, in an out-of-band call, you still cache the entire page. In an out-of-band call, you can start randomizing pieces of content. This is not necessarily the form, location, or the ID, or the name. You randomize everything. You put things in different locations. You hide elements. You put lots and lots of different mechanisms in here, and then you have a way of translating that before it goes to the origin and then posting the original content. So on the outbound, the pages all look the same. But once if they don't post the right content back to the origin, you don't let them through. You don't let them touch the origin. That way, they can't execute brute force. They can't execute, I mean, these bots are fairly dumb. They can execute JavaScript, they can store cookies, but from a logical perspective, they have to do a lot of work to be able to understand exactly what's going on when you start randomizing every field and every element, and then being able to translate that on the back end. It becomes really, really complex. So just based on this type of attack, I targeted this particular page on our protected system. So I've got a script that I'm going to pull, and I've got my two systems up here. They're pretty much average. All right, and I'll execute my secondary script against the protected system, and you'll see that one system gets CPU utilization, which is our protection mechanism, and then on the other side, the attacker or the attacked machine gets virtually no impact on that. So let's execute the attack. Okay, so I've got a little bit of a hit on my protection. It will actually stabilize after it's been hit for a little bit. We were seeing, yeah, so it'll start going back down. So it starts seeing this content, then it starts figuring out what do I need to do with it, and it'll either rate control it, block it, and then on the other side, not even a blip on our protected machine. That's because the bot it's not sending the right content to that field, so it's not posting the right information. So this isn't even hitting the infrastructure. It's hitting that page, it's trying to execute the action. Our protection mechanism is saying, you're not sending me the right stuff, I'm not going to let you through. And that's as easy as it is. So if it's not in the format that we're expecting, we won't let it through. If it's not saying the right data, we're not going to let it through. There's a lot of other stuff that's going on behind the scenes there, there you go. There's a new beta, Wedding Chaos. So you'll be able to basically randomize that content so that if it's a scraper, and we've been seeing a lot of scrapers as well, people going in there and trying to pull pricing content from a bunch of sites, that's a huge problem. The reason that it's a problem is because for all of that pricing content, so if you're trying to book a hotel or something, you're going to search for date ranges. You're going to search for places. This all hits their back-end infrastructure. If you're doing that 3 million times per day, that's a huge impact on their infrastructure because they have to search that entire data set and give you that feed, and then somebody's just scraping it, pulling it down, and using it for some competitive advantage reason. All right, so let's go back to the slides. So defense is really, really tough. Like I was saying, that the way that we were working on defining and putting that protection mechanism out there is you don't have to make any changes. You don't have to randomize that content at origin. You don't have to make those changes on your application infrastructure. This protection strategy is going to do that for you, and it's still going to allow you to cache that content at the edge of the network. That's very important from a DDoS perspective, and also offload and performance for your users. I can barely see this on my screen. So the protection strategies. You have to have protection on your application layer. So if you're using a WAF or something like that, make sure that it's scalable. Make sure that it's huge. We're seeing these attacks at the application layer over 200 gigabits per second on one customer. So if you're not looking at terabits of protection, then it's probably not going to be big enough for these scalable attacks. Anybody work for the government in here? All right. Used to? All right. Large retailers, banks. Where do you guys work? All right. So financial institutions are always a target. Government's always a target. So I work with a lot of these people. And real-time protection, scalable protection is very important, especially for our government customers. They get attacked all the time. That's fun to look at. Real-time, always-on protections. Again, seconds, milliseconds matter. If your protection, I can't remember the provider, but there's some anomaly technique that a DDoS provider uses at origin. And anytime somebody tells me that they can prevent a DDoS attack at origin, unless it's an application resource consuming attack or something like that, that is a load of crap. There is no amount of scalability that you can put at your origin that's going to be able to prevent these 200, 300 gigabit attacks. It's not feasible without impacting significantly your origin. Unless you're an ISP or something like that, you're never going to be able to get that amount of bandwidth. Question? No? Yeah. So what you need some layer of defense before you get to your data center or your cloud infrastructure or something like that, and it's got to be huge. And it's got to happen quickly. If it's using anomaly scoring or some pattern of baselining, that takes time. That could take minutes. It could take, it just depends on what that traffic profile is. I was looking at one solution that took like 10 minutes to be able to baseline traffic and then block attacks. I don't even understand that because you've already been impacted. You've already got an outage. Protecting multiple origins from an attack with one solution, that's key. So if you're using cloud infrastructure, you've got multiple data centers, you need something that's going to be able to kind of protect everything and give you visibility across all that stuff. I don't really care what you guys use, but it's got to be something that you can protect kind of all of that infrastructure that you've got sitting back there servicing customers. Banks have multiple data centers. AWS instances, what I usually like to see is high availability on your AWS or your cloud infrastructure. So you've got multiple instances running and they're all hot. And then you've got something sitting in the cloud saying, hey, is this guy healthy? Can I route traffic over there? Is my protection across everything? So you want that umbrella sitting on top, and then you've got multiple things sitting underneath servicing customers. Bot mitigation, if you have bot mitigation, it has to support cacheability. So if you're not caching stuff at the edge of the internet right now, you're just kind of wasting resources. Performance is also a key aspect there. So cache stuff at the edge, use whatever provider you want, but whatever mitigation strategy that you're going to use, it has to support caching. Make inputs harder to guess. This is a very, very difficult thing to do, especially if you're a software developer or you've got software developers working for you. This is incredibly complex, and if you don't do it right, you break caching completely, and you could break your application as well. Block bad inputs. So if somebody's sending you something that doesn't adhere to the predetermined patterns that you're expecting, just block them. Okay, so bot mitigation techniques, we kind of already covered that. So I'll do a quick recap of the stuff that we've talked about. So scalability is extremely important. Use whatever provider you want, but make sure you're caching stuff at the edge. Make sure you're caching it globally. Make sure that the protection that you're putting on there is globally scalable. Make sure that it's in the terabits per second. Make sure that you've got fee capping protection on all of your stuff. So like I was saying, AWS, their response to denial of service, and this is being recorded, it's great. So their response to denial of service is scale. Scale up. The other thing on the other side of that is, sure, we'll charge you for it. But yeah, scale up. We'll be able to satisfy that traffic load, but we'll send you a bill later. So make sure that whatever you're going to be using that's going to be defending you from that is going to have some sort of fee protection in there. The randomizing content's really hard, so and being able to do that out of band and still support cacheability is extremely hard. There are solutions out there. If you want more information, again, you have my email address. We can kind of tell you what that technique looks like and help you there. But really easy to execute. That's the thing that scares me the most, is that there's lots of attack vectors out there. There's lots of vulnerable hosts. Extremely simple scripts can cause huge impact to customers, your customers, my customers, any customers. It's scary. You know, we were seeing outages across the entire financial, you know, industry for months, just based on these little tiny scripts. And it's really hard to defend it. Okay. That attack is really easy to execute. Data exfiltration. If I get something on that box, I'm taking your database. I'm taking pretty much everything on that box. And I'm going to use it to execute my DDoS attacks. Really simple. Once I get that script on there, I can FTP stuff out. I can pull your database. I can pull your entire file system. It's kind of crazy. Targets are in all vertical, all sizes. It doesn't matter what vertical you work in or who you work for. Somebody's going to say something that's going to piss somebody off. They're going to attack you. Or it's Tuesday, and they're bored. Or it's if you work on a college campus, one of the kids is going to get, you know, go crazy and start attacking the infrastructure. Operating on the internet, it means that your site's always under attack. I get scanned. I'm probably getting scanned right now. Thanks, guys. So you're always under attack. It's funny. So customers are like, well, you know, let's put it on. Let's see what happens. And I'm like, oh, you're attacked all the time. We'll turn on protection. We'll show you exactly what's happening. And you know, somebody came to me once and says, well, what if we don't see anything? I'm like, no, we will see something. Somebody's going to scan it. So that's really not a problem. You're getting scanned all the time. I think it takes, on websites, I think it takes like 10 minutes and somebody's scanning you. And it's all automated. It's usually from, you know, it's usually from China or Russia. That's what we generally see. Or Eastern Europe. So we see quite a bit of that happening. Absolutely scan this QR code. I highly recommend it. It's my LinkedIn, don't worry. But that's my email address. Feel free, if you've got any questions, comments, if you want, I think I can send you code samples, but if you want some more information, feel free to hit me up. That's pretty much it. Do you guys have any questions about kind of what we're seeing? You know, I see quite a bit of stuff outside of just this realm. You know, front-ending 30% of all web traffic, we see quite a bit of stuff. So, yeah. So, yeah, I can tell you about, so the lawyers didn't let us do this, but I can tell you, I'll tell you a few things there. So the first thing is, can we kill UDP? So UDP is, it's stateless. I can send you any source address